Hello everyone, today I will present my homework project. The topic is this project to use three PLC programming languages to control a piston with set and reset function, and also to solve the uh, pneumatic pneumatic process in flushing. In this presentation, I will explain the project stru- structure, working principle, programming methods, hardware demonstration, and simulation research. This page shows the overall structure of my project. First, I use PLC software, which is the tin, which is TinCAT, TinCAT, to write the control programming. Then the programming was downloaded to PLC physical device. The PLC outputs signal to the double solenoid way. After that, the valve controls the real cylinder movement. At the same time, I also use Flasim as an independent simulation tools to uh, brief the pneumatic working principle. So the project include both real hardware control and software-based pneumatic simulation. This project contains three main parts. The first part is PLC software design. In this part, I use three programming languages: LD, FBD, and ST. The second part is PLC hardware control. It includes the baffle PLC, real input signals, real output signals, and the real solid. The third part is flashing pneumatic simulation. In this part, I build a pneumatic current with a double these three parts together from the complete control system. This page shows the working principle of the system. First, the system start and check the signal from S0. Then the start condition is satisfies by one set, and the cylinder moves forward. When the cylinder reaches the forward limit switch S1, Y2 is set, and the cylinder moves back. So the whole process is forward and return motion based on set and reset control logic. This page shows the PLC input and output allocation. The physical input are set to 0 ix%, and the physical outputs are a signal to qx%. The outputs are connected to the solenoid swollen coils, and the input are connected to the limit switches. This I/O allocation is very important because it connects the programming logic with the real hardware system. Without correct I/O assessment, the PLC cannot control the actual device properly. This page presents the LD program. LD means leader degrees, which is one of the most common PLC programming language. In this program, I use and receive instruction to control the forward and the backward moments of the cylinder. I also added interlocking logic. This interlocking function prevents Y1 and Y2 from being turned on at the same time, which helps protect the system and the resources serve operation. So the LD program is clean, intuitive, and suitable for electrical control logic. This page shows the FBD program. FBD means function block degree. In this means I use SR trigger blocks to realize and reset and reset function. Compare with LD, FBD is more modular and more visual in block form. It's convenient for organizing control function and make the program schedule easy to understand. So FBD is a good choice when the control logic need to be present in function way. This page presents the ST program. ST means structured text. In this language, the control logic is written by using IF10 statements. Compare with LD and FBD, ST look more like a traditional programming language. It's more suitable for complex logic, advanced calculation, and larger industrial programs. In this project, ST can also achieve the simple piston control function clear and efficacy activity. This page shows the real PLC demonstration process. First, I press the start button. Then the slider moves forward. Then the slider reaches the limit switch S1. The controller logical change the output signal. After that, the selector returns to its organized position. This demonstrates that the PLC program works correctly on the real hardware system. This page shows the FlashSim simulation. FlashSim was used to simulate and verify behavior of the pneumatic circuits. Although it's not the real hardware system, it helps us clearly also the cylinder motion and the wall switching process. It's very useful for checking the whether the pneumatic design and calculate before or to get which real implementation. So FlashSim provides an effective ways to relieve the permission principle in this project. This page gives a comparative analysis between the PLC physical prototype and the FlashSim. The PLC system uses real electrical control, while FlashSim uses simulator pneumatic control. The PLC prototype is used for actual execution, while FlashSim is used to principal verification. The signal search in the PLC system comes from real PLC outputs, while in FlashSim it comes from simulation signal. By comparing these two methods, we can see they have different roles, but they complement each other in this project. In summary, this project successful control real PLC hardware. I implement the sets and reset logical by using the programming language LD, FD, FBD, and ST. I also verify the pneumatic behavior with FlashSim simulation. So this project I complete for an industrial control cycle, including software programming, hardware execution, and simulation verification. This project helped me better understand PLC control, logic, and pneumatic system operation. Okay, thank you for this is the end of my presentation. Thank you for listening.